Here, Adam. Where are you, little Adam?
Mr. Sams?
Yeah.
What are you doing?
I'm looking for atoms because I want to see those little parts that are inside the atom, those subatomic particles.
Mr. Sams, I got news for you.
Huh.
You can't see him with that.
Yeah, I'm just seeing a bunch of fuzz. Maybe I just need to focus it.
Oh, focus?
Focus, yeah.
I don't think that's going to help you.
Why not?
Well, you see that thing? That microscope? It's not strong enough.
This is not a tunneling scanning electron microscope?
I believe not. It's just a little stereoscope. It might make your finger look big, but it's not going to do anything else. Here we go.
Hey, look at that.
Check it out.
Cool.
We can see your finger, yeah.
Yeah.
See how you can see your fingernail? But you know what? Atoms are just too small. We learned in the last podcast that atoms are itty-bitty. Remember that?
I do.
And what we're going to learn about today is not even just the atoms are itty-bitty, but the things inside of them. We're going to learn about how to count them and stuff. They're just like beyond itty-bitty.
There's a lot of dirt underneath my fingernail.
That's gross. Yeah. Okay. Yeah. So today, guys, what are we going to learn?
Subatomic particles.
Subatomic particles. Subatomic particles. Well, here we are. Today what we want to do is we want to start counting subatomic particles. So this is video podcast at 2.2. And so what are the parts of an atom? Something we do need to talk about. One thing is a thing called a proton. A proton. And a proton, if you really want to envision it, is really just like a tiny sphere inside of the nucleus of an atom. By the way, it has a spin on it. You can see this little curved deal. As you want to know, scientists believe they're spinning. So that's a proton.
Yep, they have a positive charge, by the way.
You think they have a positive?
Yeah, proton positive.
They have a positive charge. All right. A neutron. What's the story of a neutron? Also, kind of like a tiny little sphere, you would find him in the
nucleus.
Now, neutron comes from the word
neutral.
Neutral. Okay. So it has a no charge.
No charge.
Yeah.
No.
So
but it has a mass very, very close to that of a proton.
Yes, you can say that the mass of a proton is about equal to the mass of a neutron. Actually, N0 or P positive would be the appropriate symbol.
Yeah, little abbreviations for them.
Yeah, okay. And then lastly, there are electrons.
Electrons.
And I've got them like moving here. That's kind of cool, isn't it?
Oh, they're
electrons are much, much smaller than protons and neutrons. In fact, they're about 10,000 times less massive. And they are small.
Very small.
And they are abbreviated E negative.
Because they have a negative charge.
Because they have a negative charge. And where do you find them?
They're kind of buzzing around the nucleus.
On the outside.
On the outside,
somewhere.
yeah.
And they're kind of moving in the picture there.
Yeah.
Yeah, kind of cool. Now, how do we count electrons? So let's kind of learn how to count. So if I've got the periodic table, so everybody, if you do not have your periodic table, you should get your periodic table out.
Yep.
And get it out, and you need to see if we can figure out how many electrons. So let's take boron right here.
All right.
So boron is element number 5.
That's atomic number 5. That means it has 5 protons.
Okay. Actually, we're talking about electrons, Mr. Sams.
Yep.
So
if you know protons, we can find electrons.
That's true. So actually, let's just kind of talk this through. If we've got boron, if it's atomic number right here, that's the smaller number, okay, on all elements.
Yep.
So
it's a whole number.
It's a whole number, and the atomic number is equal to the number of protons, and it's also equal to the number of electrons.
Yep, that's because atoms are neutral. They don't have an overall charge, so however many positive protons they have to have an equal number of negative electrons.
So boron would have 5 protons, sorry about that line, guys, and 5 electrons.
Yep.
That's pretty easy, isn't it?
Yeah, very easy.
Okay.
Let's do one more.
Oh, go back? Okay, let's do that. Oh, I got a page for practice, but let's grab one here.
Yeah.
Let's do gold. Gold
All right.
is element 79.
Yep.
And actually, we'll throw that other number in there and we'll come back to it. Gold is element number 79. Actually, the way you abbreviate that, you put the 79 on the bottom, which is atomic number. I know your periodic table here probably is backwards. And his other number, his atomic mass, let's just kind of round that and call that 197. So, well, this is the atomic number. So the number of protons is equal to 79. And also, it's equal to the number of electrons.
So 79 protons, 79 electrons. How many neutrons are in there?
Well, actually, it's pretty easy because the weight of an atom, the mass of the atom, which is actually called the mass number.
And that's that number at the top, that 197, right?
Yeah.
Okay.
Would be equal to the number of protons plus the number of neutrons. That's a P there. So P plus neutrons, well, we know in this case that the mass number is 197.
Okay, we know the protons.
Protons
79.
would be 79 plus the neutrons.
All right, so if we could just subtract 79.
Yeah, so if you just subtract 79 from both sides, a little algebra here, right? Minus 79. Of course, this comes out to 0. So 197 minus 79
Yep.
would be your answer.
116? 118? 118.
118, yeah. So we don't have the calculator showing on there. We could, but it's just 118. So the number of neutrons was just simply the mass number minus the atomic number equals the neutrons. That's not too bad.
Oh,
All right.
easy.
Let's do one more maybe. Just grab one. Which one do you want to do, Mr. Sims?
This one's saying counting protons, iron.
Iron. Iron. Iron is an interesting element because its Fe comes from the word ferrous.
Sorry, that's Iron Man.
Iron Man. Oh, I was thinking like iron, like heavy metal.
Yeah.
There you go. Okay, yeah. All right, so iron, let's draw him out. It'd be Fe 26, put the number there, and 56. So he's going to have 26 protons.
26 protons, because that's its atomic number.
26
Electrons, same thing.
Electrons. And he's
And
going to have 56
30
minus 26,
yeah, 30.
which is 30
Neutrons.
neutrons.
Cool.
That's not too bad.
No, not at all.
All right.
All right. Yeah, that's
think.
probably good enough.
Yeah, I think we've done that. So, guys,
Yeah.
it's just add, subtract, and you're good on that.
All right, now there's one more thing we need to show you. And
Yeah.
sometimes things have a charge, a plus or a minus on them. Now, the way we get a plus or a minus charge is we gain or we lose electrons. The only thing in a chemical change that's going to move around are electrons. Now, we can move the protons and neutrons in nuclear reactions, but that's kind of beyond the scope of where we're going right now. So, the only way we're going to change the charge is by gaining or losing electrons. And if we remember correctly, the electrons are negatively charged. So, if I have something with a negative charge, let's say maybe chloride, Cl minus, what that is, that's a chlorine atom with a negative charge. So how did it get its negative charge?
Well, let's actually go back and look at chlorine on
Okay.
the periodic table. I think that
All right.
would make life a lot easier. Here's a couple screens
Okay.
back. So here's chlorine. He's 17 and 35, let's say. We'll talk later in the next podcast about how they kind of go together. So he's 17 and 35, right?
Mm-hmm.
And so we would say there were 17 protons.
because that's its atomic number. That never changes.
It says 17. 17.
The pen is being strange.
Yeah,
today.
I don't know. 17 protons. But here's the trick on this one, because in order for him to negative charge, he needs to have
An
one
extra
more, an
electron.
extra electron.
So
It's kinda
normally
weird.
it would have 17 electrons as well, but with the negative charge it has 18 electrons.
This is like -1. And so if you add 17 plus -18, that adds up to -1. You don't worry about the neutrons because they have no charge, so
Right.
they don't add to the, or subtract from the charge.
Right.
Now notice what Mr. Sams did here is he only played around with electrons.
Right.
And it's kind of a weird thing.
Right.
It's a weird thing because...
You add one and you get more negative.
Yeah, it's kind of weird.
Yeah.
Yeah.
But
Well,
that's
actually,
because
let's,
they're negatively
Let's do a
charged.
really quick video to illustrate that.
Okay.
Mr. Sams,
Yes,
you have an ugly nose.
I know, and I'm feeling sad about it. I'm feeling very negative.
You're
about
feeling
it.
negative because
Yes.
you have an ugly nose. You know, I think that problem can be rectified.
Yes.
How do you think
I
so?
think I can give my ugly nose away.
How do you feel now?
I feel positive.
Oh, yes,
But I'm
'cause-
going to give it to you. And now how do you feel? Yes, see, now you have the duct tape nose.
I'm ugly.
And you
oh, my
feel-
friends are gonna make fun of me. I feel so negative.
Exactly. So the ugly nose is like an electron.
Yeah.
If you give the electron away, the thing that got it is now
Now I
negative.
feel negative.
And
Because
since I got rid of it, I feel
positive.
positive.
You see, yeah, it's
Exactly.
kind of an odd backwards thing. When you
Yeah.
get something, you feel bad, and when you lose it, you feel good. But if it's an ugly nose, it makes sense, doesn't
Perfect.
it? Okay. Well, that was kind of funny, Mr. Sims.
Yeah.
So
Duct tape.
notice the chloride, he has the negative charge. He has gained one electron, or one
Right.
ugly nose. And so he feels
more negative.
bad. That was like when I lost, or I gained the electron, and I
Exactly.
felt pretty bad.
Yeah. Now, on the other side of that is
Yeah.
when I got rid of that ugly electron nose.
Actually, let's
I
do
got
it the reverse here. Let's say that there's an ion, there is,
Okay.
called calcium, and calcium has a charge of positive 2. Now, if you look at the periodic table, his numbers are 20 and 40 right here. Now, that means he's going to have 20 protons. Notice the protons don't ever change in the atomic number.
Always
the same. Now, but the electrons are
right.
weird.
With the +2 charge, that means it got rid of 2 negatively charged electrons. So it's going to have 18 electrons.
He's got only 18 electrons. Actually, it's interesting. These two numbers are the same. That's a whole other discussion later on in this year. But the point here is you've got 18 electrons. And also, I wanted to make a note here, the positive 2 charge is important because you can have not just a positive or a negative charge, but you got positive 1, 2, 3, negative 1, 2, 3, etc. And so you're only losing or gaining electrons. This is, Mr. Sam said, 2 ugly noses, maybe 2 ugly ears. I don't know if we want to take our analogy.
I like my ears.
You like your ears? Okay, well, I think they're ugly. So you need to give them away. So anyways, or we can make them ugly by putting duct tape on them.
We could do that, yeah.
Yeah,
Exactly.
so anyways. All right, so that's it for this podcast. We'll see you in class. Bye.